So part B, we've been given our first assumption, and that equals the thing with all those k's in it there. We're trying to find the sum from r equals 1 to k plus 1. And same idea as before, we break this up into from r equals 1 to k plus the extra one on the end, which is when k plus 1 is put into this. So that's k plus 1 all squared, k plus 1 minus 1, that's just k. Now, what was that big thing we assumed in the first bit? Well, it was, I'll read the right line, it was 1/12 k plus 1, 3k plus 2, and k minus 1. That's a lot, isn't it? And we're adding k and k plus 1 all squared, that thing there, and I'm going to make it easy by putting a 12 over 12 outside it. So what factors have we got here? So we can take out the 12th, we can take out the k and a k plus 1, the k and a k plus 1. What does that leave us with, that bit there? You know we're going to have to multiply it out on the next line, don't you? So, but for now I'll just write it. Plus, now we've already got the k and one of the k plus 1s, so that's just 12 lots of k plus 1 left at the end there. 12k, k plus 1. Right, multiplying this out, what do we get? 3k squared plus 2k minus 3k, so that's minus k minus 2 plus 12k plus 12. So grand total, 3k squared plus 11k plus 10. That is almost certainly going to factorize, and it's going to factorize into 3k and k. We're going to get a 5 and a 2. They're both going to be positive, and so my answer here is I've got 12k, k plus 1, k plus 2, 3k plus 5. And look back at the original one. The original one, I'm just reading this from the original thing now, which is 1/12 of, well, it was k minus 1, the one on the end, plus 1. So, say again. K plus 1 minus 1, and that's that one there. And then there was k, which is now one more than that. That's that one there. And there was a k plus 1, k plus 1 plus 1, which is that one there. And there was a 3k plus 2, and that gives us 3k plus 3 plus 2, which is 5. That's that one there. So all I've done on that last line there is rewritten the very first thing, but put a k plus 1 instead of a k in each of it.